Let's put our knowledge that we've got so far on vectors into a practical application here and a question. We've got a hiker who's lost in the bush and so walks due east for 2 kilometres and then turns and walks north for 4 kilometres. What is the displacement of the hiker from his starting point? We've need to pick up some keywords here, and the word displacement means that we're talking about vectors. This is a vector situation. And with a lot of these questions, it's really important to put down a good diagram, and a good size diagram which has got all the information. So we've got to set up some sort of reference for where north, south, east and west, and I think it's probably just quite acceptable to always put, or most times anyway, put north at the top, east. So we put the points of the compass down. So we got south and we got west over there. So the hiker travels due east for 2. So this is the hiker's starting point. So that's the start, and travels east for 2 kilometres. And then stops and turns and walks north for 4 kilometres. So not to scale, so we'll put it up there. So 4 kilometres. So here we've got some vector addition going on. We know straight away that's a right angle because there's a right angle between the north, south, east, west. So we can quite rightly claim that to be a right angle, and we want to know what is the displacement of the hiker from his starting point. So this is where he is now, this is where he started, so the displacement that we're after is that vector there. So what we've got to do, and now because we're talking about displacement, we know that there is magnitude, and also we've got to come up with some direction. So we've got to find 2 things when we're talking about displacement. We've got to find the magnitude and we've got to work out the direction. Now, by looking at the diagram, we've got a right angle and we've got a triangle there, so straight away you should be starting to think, right, we've got Pythagoras going on here, and it's just the hypotenuse that we're after as far as the magnitude. So if we call this is, we'll call it A, then he goes to B, and then he goes to C. So we've got AB squared plus BC squared, and that'll be equal to AC squared. So we've got AB is equal to 2, BC is 4, so we've got 16 plus another 2 squared, which is 4, 20, so we've got 20 equals AC squared. So AC square root of 20. Now, when we try to simplify that using surds, we know that 20, the biggest square number that goes into 20 is 4. 4 is a square number. The square numbers are just perfect squares. So you've got 1, which is a trivial example here, but we've got 1, 4, 3 squared 9 is a square number, 16 is a square number. So the biggest square number that divides evenly into 20 is 4 times 5, so root 20 equals root 4 times root 5, and that's equal to 2 root 5. So AC will be equal to, in its simplest form, 2 root 5. And that will be in kilometres. So we've got the magnitude of the vector AC, and now we've got to work out some sort of direction. So if we were to superimpose the north, south, east, west over A, we know that vector AC will be theta degrees north of east. So this is east going up here, so it'll be theta north. How do we work out theta? Once again, we've got a right angle triangle, we've got opposite and adjacent. So that trig ratio is tan, so we know that the tan of theta is equal to opposite over adjacent. So that's equal to 2. Now from that, we can imply that theta is the angle whose tan is, and that's how we write that, inverse tan, the angle whose tan is 2. Now if we put in shift on your calculator, shift tan, will give you the angle whose tan is, and we'll get 63.4 degrees. So the final part of the working of this question is to actually state the answer. So we've got a hiker in this situation. We haven't been given in the question any A, B, C, so we don't mention those. We just use those to be able to convey what we're doing. So we've got the hiker is 2√5 kilometres. That's the exact answer from the starting point. At an angle of 63.4 degrees north of east. So north of east, south of east. North of west, south of west. Okay.